students, how you all are doing? I hope everybody is doing fine. So what have I got for you today? I have got the CBSE pattern questionnaire, right? A pattern exercise, and that too on the chapter Polymers. So I hope everybody has revised the chapter, because here I am going to test your knowledge. Yes, you will be doing it along with me, right? Let's start with the very first question. What do I have? Yes, it says question number 1 to 3, 1 mark. So I have got a pattern exercise for you. That means I will be dealing with 1 mark, 2 mark, 3 mark, 4 mark, and in fact 5 marks, right? So first one, which of the following is fiber? So there is not a straight question, but depending upon the type of the examples that it has. Fine. So which of the following is a fiber? And yes, I need to find out the fiber. Out of the 3, what do you think? Nylon, yes. This is the answer. This is the answer for a fiber. Whereas if I talk about the neoprene, it's an elastomer, right? And if I talk about PVC, it is thermoplastic, right? So this thing, the differences in the different kind of polymers, how the polymers are classified on the basis of molecular forces. This very topic is very important from the exam point of view, right? Now, the next question, let's have the next question for. Okay, again another a 1 mark question. So what is it saying? Yeah, this is a homopolymer or a copolymer. So first of all, you should have a knowledge of what a homopolymer is. Homopolymer means having same monomers, yes, which are connected together, added together, addition polymerization, remember? Copolymer means having different monomers, right? And this is known as the copolymerization. Fine. So what is it? So we just have discussed this example. This is PVC. PVC, the full form, polyvinyl chloride. Yes? And yes, what is vinyl chloride? So what is the basic monomeric unit of it? Let's just try to form it. So this is vinyl chloride. And yes, I needed N units. In the presence of a catalyst in some pressure, I get is the polymerization. And yes, we get the answer here, that is this particular PVC, which is like this. N units of it. Clear? Similar? Yes? Yes, this is the answer. Now the next thing. So the next one, what do I have? Next question. Okay. So it's, yeah, in nylon 6,6, what does the designation 6,6 means? So it's a good question. What do you refer by, what do you mean by this 6,6? Let's try to have the monomers for it, right? We already have discussed that in the sessions, right? So nylon 6,6 is formed by 2 kinds of monomers. One is, what is this? Hexamethylene diamine. Hexamethylene diamine, fine, along with another monomeric unit, which is, so basically this is a copolymerization, fine, this acid. And what is this acid known as? It's adipic. What is common in both of them? Can you judge? It's the number of carbons, yes, and that is what the 6 denotes. See here, 6 carbons in total, 6 carbons, 4 plus 2, 6 carbons in total, and that is what nylon 6,6 denotes. And yes, we already have done this, another example in this case, nylon 6,10. So 10 stands for, it's the sebacic acid, yes, having the 10 carbon atoms. Clear? Let's move further then. What do I have in the next question? Yeah, now it says question 4 to 5, it's of 2 marks. Differentiate between molecular structures and behaviors of thermoplastic and thermosetting polymers. So, it is a very important question first of all. As I told you, depending upon the molecular forces, so there is thermoplastic and thermosetting. Thermoplastic, so first of all, on the basis of structures, they are linear with few cross links. Yes, done with the structure, right? I have denoted the structure, the type of structure over here. Here the structure will be heavily branched, fine. Clear about it? Now the next is, yeah, on the type of behavior they have. So the behavior is thermoplastic, it gets soft on heating, yes, and regain property back on cooling, right? So that is what another behavior of it is, yes, and the example. So just think about the example, we just have done this. Now the property of thermosetting. In thermosetting what happens is they get soft on heating, yes, they also, but loses its property on cooling, right? Now it does not regain its property, it becomes a solid hard mass which is of no use, right? So loses its property on cooling, right? And on cooling it becomes a hard mass, fine. And yes, the example, yes, it's PVC, right? And if I talk about the thermosetting, it's the bakelite, yes, and this bakelite is used in the electrical switches mostly, right? So I hope everybody has got this. Let's move on further. So what do I have in the next question? Let's try to have the very next question. Question number 5, name the subgroups into which polymers are classified on the basis of magnitude of intermolecular forces. On the basis of intermolecular forces, I told you that this is very important one. Again, mark this as important. So I just need to name the subgroups: elastomers, kind of rubbery, fibers, yes, thermoplastic, we just have discussed, thermoplastic, and finally the thermosetting. Clear? So let's talk about the forces in between them. Elastomer, weakest, right? Weak van der Waals forces, strongest in fibers, in between, and here also somewhat in between, but yes, these have got a little less forces, fine. So yeah, so it will be, thermoplastic will be lying somewhere in their middle. And yes, along with these forces, what I can do is I can have some examples. Example, Buna S, and rubber. In rubber I can have is neoprene, right, etc, etc. And in fibers what do I have? Nylon, nylon we can have, polyester we can have, thermoplastic, PVC, polyethylene, polystyrene, right, etc. Thermosetting, bakelite, urea formaldehyde resin, yes, all those resins we have discussed again lie under the category of thermosetting. Formaldehyde resin, yes, clear? So I'm just rubbing this off. I hope everybody has noted this down. Let's talk about the next question then. So the next question says, yeah, now we have got the 3-mark question and it's a jackpot for me. Why? Because here straight away I need to write the monomers and my work is done. No theory, no any kind of an explanation I have to do, right? Just the structures if I know, I'll get the full marks. First one, dacron. Dacron, it has got 2 monomers. One is, see here, ethylene glycol plus terphthalic acid, right? This is important. Dacron is important. So that is ethylene glycol and terphthalic acid, right? And this is ethylene glycol. Melamine formaldehyde polymer. As the name suggests itself, these are the monomers. Let's draw the structure. So that is what the melamine is. We have done this before. Yes, along with formaldehyde, HCHO, and these are the monomers. After their reaction, what do we get is, we get something like this, see, NH, CH2OH, fine. And that is what a resin intermediate is, and after that we get the entire polymer, clear? Buna N. In Buna N, we get is 1,3 butadiene, yes, and N stands for acrylonitrile, right? So it is like this, 1,3 butadiene, right, along with acrylonitrile. So it is like this. So it's just like the polyvinyl chloride, just the vinyl chloride. Chloride replaced with CN, now the name changes to acrylonitrile. So it's like this, CN. Fine? Okay. Here the attachment would be not through the N but CN. Clear about it? So these are the monomers. All the 3 parts done, 3 marks full I've got, right? I hope everybody has got full 3 marks here in this question. Let's move on to the 7th question now. What is the role of tertiary butyl peroxide in the polymerization of ethene? Now what is it? We have discussed about the benzoyl chloride in the polymerization. From where does this tertiary butyl peroxide has come up? So basically, just like the role of benzoyl peroxide, what does benzoyl peroxide do in the polymerization process? It is a free radical initiator, right? Yes, so it's a free radical initiator along with the property of a catalyst, yes. So not just only the benzoyl peroxide, but tertiary butyl peroxide can also act as the same. Also one more, what I would like to give you here is acetyl peroxide can also act as an initiator. Fine, clear? So this is important, this needs to be remembered, these 3 examples. Identify the monomers in the following. You see, it's the thing that we have already done. It's just a condensed polymer. If you look here very carefully, I've got 2 monomers. One is hexamethylene diamine, remember? Right? NH2, NH2 was there, right? And here adipic acid, yes? Remember or not? So that is what the monomers are. Clear? The last one, arrange the following polymers in the increasing order of their intermolecular forces on the basis of whether it is elastomer, whether it is fiber, whether it is thermoplastic or thermosetting. Let's discuss here. Polystyrene. So polyvinyl chloride, polythene, all these kind of polys, right? They are included in the thermoplastic. First thing, right? Done. Terylene, what is it? So terylene here, it's a kind of a fiber, right? Dacron. We have done the dacron. Dacron is nothing but terylene. It's a fiber, right? Buna S, it's a rubber. Oh, sorry, not exactly the rubber, but an elastomer, right? So we know the forces. This is the weakest, this is the strongest, this is somewhere lying in the middle. So what is this? Yeah, terylene followed by, yeah, it's polystyrene, and finally the weakest, Buna S. Clear? So that is what the order is. I hope everybody has got it. If not, just try to remember the examples, then you will get it. Fine. Let's move on. What I have got here is the question number, sorry, yeah, 7th we have done, 8th, right? Write the names and the structures of the monomers and your work is done. Again, a very simple question. It will fetch you complete 3 marks if you know it. Bakelite. What are the names of the structures of the monomers? So you know, bakelite is a formaldehyde resin, right? Phenol formaldehyde resin, just like the Novolac. So it's basically phenol, yes, formaldehyde. That is it. Write the names and the structures of the monomers. Yeah, we just need the monomers basically, right? So what do we get from here is the bakelite. I am just giving you an idea about how the bakelite looks. So it's something like this. OH and so on, right? Along with there will be the connections over here. Fine. And yeah, the connections will be somehow like this. And CH2 and a similar kind of arrangement will be here as well, and OH downwards. Fine, like this. Clear? Clear? Something like this, a symmetric one. Fine? Done? PHBV. So it's very important. What is it? Full form, polyhydroxy, right? So it's starting with poly. Now comes a beta. Hydroxy, butyrate, co, that means condensed with beta hydroxy valerate. Yes, so PHBV. Fine. So let's try to have its monomers then. So the monomers are very typical here. It is 3-hydroxy butanoic acid. Can you draw that? So 3-hydroxy butanoic acid, how does it look like? 3-hydroxy. Starting from here, 1, 2, 3. Right? You can complete the valencies on your own. Let's take up the next monomer. It is 3-hydroxy pentanoic acid. You need to remember this, right? And yes, you can very well form the formula for it as well. I hope that is clear. Done. Now comes a Teflon. What is this Teflon? Teflon is tetrafluoroethene. Polytetrafluoroethene, PTFE. PTFE. Polytetrafluoroethene. What is ethene? Right? I need is tetrafluoro of it. Tetrafluoro means all the hydrogens will be replaced by fluorines. Fine. Can I make a polymer out of that? Definitely yes. Like that. So that is what Teflon is, PTFE. Clear? So done with it. All the 3 options done, full 3 marks I've got. I hope you too have got this. Now comes up question number 9th. And yes, what do I have here? See? So it's a value based question basically. After the ban on plastic bags, see here, read carefully. Students of one school decided to make the people aware of the harmful effects of the plastic bags on the environment and Yamuna river. So they found that plastic bags are very harmful for the environment, and they then decided to make each and everyone aware of it. So to make the awareness more impactful, they organized a rally. There was a rally organized by joining the hands with other schools and distributed the paper bags to the vegetable vendors, shopkeepers and departmental stores. All the students pledged not to use polythene bags in future to save the Yamuna river, which water is getting disintegrated and it's affecting the marine life, in fact indirectly us. How? Because there is all the cultivation around the Yamuna river which is going on, and that cultivation has got chemicals which is absorbed by the roots of the plants directly from the Yamuna river, in which these plastic bags are dumped. And that is why these vegetables are getting harmful day by day for us. They have got some toxic metals like mercury, lead, arsenic in those, right? So that is why they did this kind of a rally thing. After reading this above passage, answer the following questions. What values are shown by the students first of all? The students' values, first of all, they were aware of the fact, right? They had got a great knowledge about it, and they were concerned about the society. About the people, right? And in fact, not just the people but environment. Clear? So these were the values. What are biodegradable polymers? Give you can you give one example of that? Biodegradable means they can be degraded in the environment. They are not that much harmful for the environment. They can be disintegrated by the bacteria, right? And what can you give, what example can you give over here? We already have done this. Can you recall what all questions we have done? It's PHBV, which is a kind of a biodegradable polymer, PHBV, and also I have got is for you is nylon to nylon 6. This is also a biodegradable polymer. Nylon 2 is glycine, whereas nylon 6 stands for the caproic acid, right? Aminocaproic acid. And yes, second part also done. Third part, is polyethylene a condensation or an addition polymer? I have told you already this, that condensation polymer means where the copolymers are existing, but addition is the one where the same kind of homopolymers are existing and they are being added if the monomeric units are unsaturated. That means if they have got double or the triple bonds, then they get added with one another, forming a polymeric chain, and that is what the polyethylene is. That here ethene, different units of ethene, that means n units they combine to give polyethylene. It's a kind of an addition reaction which is happening, right? And this double bond disappears basically, polyethylene. Clear? Done with the fact. Question number 9 also done. Let's move on to the very last question of this entire questionnaire round. And yes, what do I have here? A 5-mark question. What is the repeating unit in the condensation polymer obtained by combining this? They have randomly given the succinic acid and ethylene diamine. I need to polymerize it basically, right? Let's polymerize that. So it is, yeah. Right? So for polymerization, we have to write these groups separately like this. And this is the succinic acid along with ethylene diamine, right? So it is like this, CH2, CH2, NH2, fine. Can you form a peptide linkage over here? Yes, I can form it like this, fine. So it's like this, which will be formed, yeah. Along with what? Along with what? See, this will be n number of units, right? CH2, CH2, CO, NH, CH2, CH2, NH. Clear? And that is what the repeating units will be. This unit will be repeated again and again. Clear? So that is how I needed to polymerize it. What is the role of sulfur in the vulcanization? What does sulfur do? So basically vulcanized rubber is the better one from that of the natural rubber. So I have made it better. How? By giving it tensile strength and cross links in between, right, due to which it has stiffened, it has become stiff, right, and it has got tensile strength, and even if it's subject to so much of harsh force, it is non-abrasive basically, it is non-abrasive, right. So that is why the vulcanization is done. You can also show the vulcanization like this, see here. So something like this, CH2 and C, like this. That is how the sulfur will be connected with the other part of the isoprenic group, right? Isoprene is the very basic one which forms the natural rubber. I hope you remember this. Second part is also done. Excuse me. Next part, identify the monomers in the following polymers. So we already have done this. What is this? Ethylene glycol, remember? Yes. And this is COOH. COOH. Tertialic acid, it's dacron. I hope everybody remembers that. The last one now, arrange the following polymers in increasing order of their intermolecular forces. Again a similar kind of a question. So we know what here? Polyethylene, I told you all these poly substances, polyethylene, polyvinyl chloride and all that stuff. It's thermosetting. Yes. Neoprene, I told you it's a rubber, so it's an elastomer. Whereas terylene, it's what? It's a fiber, right? We have done this. Terylene is nothing but this, dacron only, fine. So first one having the highest strength, fiber. Second one, something in between. Okay, so it's not, it's not thermosetting, it's thermoplastic. Right? So it is second, somewhere lying in the middle, and elastomer having the weakest forces of interaction intermolecular forces, least, number 3, right? So you can very well arrange that in order. Clear about it? So I hope everybody has got the entire questionnaire. I hope that you all are able to do these questions. If not, again just go through them, revise once again. If you've got any kind of a query, you can anytime reach out to me. You can post any question on our website so that I may be able to get it that yes, you are having some difficulty in any of these questions or maybe some other questions, right? So I'm open for that. So just revise what we have done so far. Have a nice day.